Chapter 8, Day 1. We're going to go back here and talk about some quadratic functions, which we've touched on a few times throughout the year. I'm going to skip right down here. It says the graph of a quadratic function is called a parabola. What is a parabola? It's that U shape that you guys will see. That's what a parabola is. Right? So we're going to be using Desmos a lot. So a lot of graphing. And we're going to always be comparing to the parent function. So the parent function is like the original to a group of functions. It's the simplest function in that family. So we use x squared. What are some key characteristics? Well, down here, for example, it's got a minimum point at 0, 0. Okay, we could talk about domain. Domain is our possible x's. And if we use interval notation, which is different than writing it as it's going to look the same, we go from negative infinity to positive infinity. And remember, if it includes that point, interval notation is brackets. But infinity isn't a specific point, so you can't use brackets. Like if this started at 0 and it didn't include that point, it would be parentheses like that. But if it included the point, it would be a bracket. But whenever we have negative infinity and infinity, it's always the curve. So the range is our possible y value. So in this case, the smallest y that we have is 0, and that is included as a part of our graph. So now we got the bracket around it, and then it goes to infinity. So there's a couple of the key characteristics. And then we're going to come down here, and we're going to take 2x squared, which is very similar. So you can come here over to your graphing calculator. You don't need to log into Desmos. All right, and oh, I don't want that. Where is it at here? There it is. Aha. So we're going to do 2x squared. All right, and then we will be done here. We'll go back here. And let's forget to use this one. There it is. Sorry. Hit the setting button and go to the table. And this is the table that we need. So we need 8, 2, 0, 2, and 8. So that comes over here. 8, 2, 0, 2, and 8. So let's talk about some key characteristics of this graph. All right. Remember our vertex, it doesn't change in this case. Our vertex is right here. Our vertex is where it changes from one spot to another. It's our lowest value in this case because we're dealing with a minimum. Our axis of symmetry is that dotted line. And in this case, our axis of symmetry is when x equals 0. Our domain, negative infinity to infinity. Our range is the same, 0 to infinity. And those are always going to be the same unless we start doing x squared like plus 2. Then this 0 would change. We have a minimum value at 0, 0. And now the last thing, it says interval where the graph increases. And this is one where I think there's more than one correct answer here. So they want to know the interval where the graph is increasing. So we're talking about x values here. So it starts to increase. At 0, 0, it's not doing anything. So to me, the interval that I would write is 0 to infinity. That graph is always increasing starting after 0. Because at 0, 0, it's not moving. I also will see people write it this way, and that's the one I wouldn't mark it wrong. Okay. But really, in my opinion, I've seen it both ways. I'm not saying one way is right, one way is wrong. I will do it this way. So then where it decreases, we're at negative infinity to 0. And again, 0, 0 is not going either direction. It's not at a point where it's increasing or decreasing. So that's how I'm going to do that graph there. Okay. So again, now if I change this and I come here, I just go back to the same graph. Nope, it's gone. Okay, now we're going to do 1/2, which you could put it in parentheses here. 1/2 x squared. So there's that curve that I need. Now I hit the edit list. And I take it to a table. And you'll notice now it's wider. That's something we'll get into on Monday. There goes 2.5, 0.5, and 2. So back over here. 2.5, 0.5, and 2. And the thing is about this one now, it's just, this is the parent function. So now over here, you'll notice it gets a little bit wider. And if I took it one further, like if we came back to this graph here, if I entered 3, it's going to be 4.5. If I entered 4, it's going to be 8. That's one that will be helpful. So if I enter 4, it's going to be like over here. So you notice it just kind of, we're going to sketch that graph, and it gets a little bit wider. And it would continue to get wider. So on some of these, the vertex doesn't change. Our vertex is still 0, 0. That's a point. Our axis of symmetry is still x equals 0. That's that dotted line. Our domain, our possible x's, is negative infinity to infinity. Our range starts at 0 and does include that point. Goes to infinity. Still have a minimum value at 0, 0. The graph still increases starting at 0, going all the way to infinity. And it decreases from negative infinity to 0. Last one we're going to do. So we have negative x squared now. So what happens if you take x squared and we make it negative? And notice it flips this upside down. So now our numbers are negative. So we're going to be careful here. I changed that number, so I'll change that back. Negative 4, negative 1, 0. Negative 4, negative 1, 0, negative 1, and negative 4. So now this one is the same as what you would have up here, except it is flipped over. So we are at negative 2, negative 4. Like so. It's an upside down U. So this is going to change things a little bit finally. But the vertex doesn't change. The axis of symmetry doesn't change. Our domain, negative infinity to infinity, our possible x's doesn't change. But then our range, what are our possible y values? Well, now they're going that way. So it still starts at 0. Then it goes to negative infinity. Okay, or some would argue that put the smaller number first. Kind of tomato on that one. But now we have a maximum value. Our maximum value is still 0, 0. But now where does the graph increase? Okay, because now we flipped it over. So where is the graph increasing? This one's a little tricky. It's actually increasing over here. Okay, so we start at negative infinity and go to 0. And then where are we decreasing? And it's the other opposite. So you'll notice if we compare this one up here, it increased from 0 to infinity over here. And now, where does it increase? From here. Okay. The values are increasing because we're working from a negative number working back up towards 0. Okay, for today we'll skip some of these pages that we'll be coming back to. And you're just going to do the exact same thing on 1, 2, and 3 on this page. So just 3 of these. Use Desmos, fill it all in, and do the same things that I did. And that is all. Have a great day.